This third problem gives an example of a level 3 out of 25 difficulty. The theme is Friday the 13th, which in Western culture is considered a very unlucky day. In Western culture, 13 is a very unlucky number. And it would be the equivalent of in China of 4. Friday the 13th, for whatever reason, is considered a very unlucky 13th day. And I looked at my calendar. April 13th of the year 1900 was a Friday. Then what day of the week is January 1st, 1900? What day of the week did it start? At first you will look at this and say, this is not so difficult of a question. We just have to write down how many days there are in each month. So let's start. January 1 all the way to April 13. So I'll need to know about January, February, March, and April. So how many days are there in each of those months? January has 31 days. February has 28 days. March has 31 days. And April, here what we're talking about is April 13th. We want to go to the 13th day. Actually, at this point, you worry a little bit. Because whenever you do this kind of question, you're always a little bit worried of whether you will be off by 1. Am I supposed to count the 13? Or am I supposed to go to 12? Or 14? So here, even though I wrote 13, let's remember, this 13th is the day I want to go to. Let me even write that down here. This is go to this day. It is Friday. I'm emphasizing that because sometimes when I'm calculating things, it's useful to count the days themselves, like the 13th, the 12th. Sometimes it's useful to count the gaps. Gaps are moving from one day to another. For example, if I have 2 days right next to each other, the 12th and the 13th, there are 2 days, but only 1 gap. Okay? But I should also say, there's something else to be careful about this too. February doesn't always have 28 days. Some Februaries have 29 days. Which Februaries have 29 days? You probably are used to the idea that leap year is whenever it's a multiple of 4. Oh, 1900 is a multiple of 4. So then does this mean that this is 29? Actually, something I will share right now is that this question was very carefully chosen so that in case you didn't yet know, I want to teach you and let you know that there is an exception to this rule. Very important to know whenever you do such problems, that the leap years are the multiples of 4 except the multiples of 100, which those multiples of 100 are not leap years. Well, that's not the end of the story. Actually, there's another except. Except multiples of 400, which are leap years. Okay, so this is the rule on leap years. You might ask, what about things like multiples of 2000? Actually, that gets very interesting because the notion of leap years was invented only not so long ago. And so actually in the year 0, or 2,000 years ago, people didn't even know what leap years were. In fact, even keeping track of calendars was completely different. I'm sharing this because I want this is a rather normal question, but I also want to share a bit of history and to also share a bit of why such things are true. At the end, I will talk a little bit more about this leap years. But for the time being, right now, I look at this and I say the year 1900 is in this second exception. And so, no, it's not 29, it's 28. So now let's just finish the problem. Again, I want to show a few ways to finish this question. I have all of these days, and I say that when I add it all together, it's Friday. I said the word add it all together. So let's indeed add them all together. 31, 28, 31, and 13. If you add these all together, well, what you will see is this makes 10, 13, carrying a 1, and 1, 3, 2 is 6. Notice how I'm adding these together. I'm giving you a few tricks. If I see 1, 2, and 3, I know that's always 6. So here's a 6, and 3, 1 is a 4. 6 plus 4 is 10. 103. Okay, and so if I have 103, now I would like to know, what is that if I think about weeks? Weeks are with 7. So I want to take 103 and divide it by 7 and find out what is the remainder. 7 times 1 is 7, remainder 3, 33, and 7 times 4 is 28. Remainder is 5. Okay? As I'm doing this, I'm also going to show you other ways to check that what I have done is correct. Do I believe that it's 5? Well, actually, 7 and 14 is another one of these numbers, pairs of numbers, that will be your friends. 7 times 14 is a very, very nice number, close to 100. If you can see what this is, 7 times 14 is equal to 7 times 7 times 2. 7, 7 is 49 times 2. Remember, I said this is close to 100. 49 is very close to 50. This is 98. So a nice thing to know is that with your 7s, you can get very close to 100 at 98. And so a way of checking this is that if I know 98 is a multiple of 7, then here's 5 more. Okay, it's correct. Notice how as I'm doing this, I'm doing intermediate checks using what I'm familiar with, and I do final checks with different ways of doing the problem. This is how you get all of the questions right, which is, of course, the goal. So now if I have this 5, what do I do with the 5? This is telling me that if I were to write down my calendar, I can think of it in this picture like this. If I were to write down my calendar, here is Friday the 13th, and it's on this F for Friday, which is also the 5th day of the week. Now, as I'm taking away these 7s, the thing that you want to be a little bit careful of is, well, what do I do with this 5? Am I supposed to subtract the 5 and get 0? Or something else? One way to think of this is that whenever I have 7s, I can pretend those are not there at all. And so, for example, if I think of this Friday the 13th as also the 5th day, I'll do it like this, 5th day, then if I'm actually interested not in the 5th day, but the 1st day, then you can see what happens. 5, 4, 3, 2, 1. That's then the 1st day. And the day of the week, that is not Friday the 5th, but it's Thursday, 4th day of the week, Wednesday, 3rd day of the week, Tuesday, 2nd day of the week, Monday, 1st day of the week. I will say, especially for you who are familiar with 星期一, 星期二, this is fairly easy because it's easier for you to subtract 星期, the numbers, than to subtract Friday. But in any case, if that is the 5th, then the answer should be the 1st, because I said all of these 7s don't matter. And so the answer to the whole question is actually Monday. Well, let me still talk about more ways to be careful here, because actually, if you ask this question to even very good students, oftentimes you will get answers like Sunday, Monday, or Tuesday. And the mistake here is when you forget about adding 1 or subtracting 1. So I want to talk about that in a little bit more detail. I had talked about gaps. To me, when I do these problems, I like to just add and subtract, and so I like to count gaps. So let me go back to the previous picture. I told you I want to go to this day, and it's Friday, but I want to go there from the 1st day. So actually, usually the way that I think about this is the usual way is I don't write 13 here. Here what I'm counting is I want to count gaps. And if I'm going to count gaps, I need to do another -1 at the end. It's just like if I have 2 days, the 12th and the 13th. 2 days, but only 1 gap. So I always want this, and that will tell me how many gaps to move by. If I do it this way, then my same thing that I calculate will have after this a -1 to get 102. And this will have another -1 to get a 4. And so now since I do gaps, I already know if I am at 星期五, Friday, I want to move 4 gaps back. So 5 minus 4 is 1. That's the other way of doing it. I find that whenever you're very careful in explaining, are you counting gaps or days, you don't make mistake. I want to show you one more way of doing this also, which actually saves you the work of all this addition. The other way is I already know that I'm already going to divide by 7 and only count the remainder. So the trick you can use here is you don't have to add all these big numbers. What you can do instead is you can say 28. What will that do if I'm going to divide by 7 anyway? 28 is already a multiple of 7. Let's just do 0. Don't even add the 28. And you may have noticed this in your life, where if you had a day of the week in January, most of the time, that day has the same day of the week in March, because February has 20. Actually, that's not quite true. If you have a day of the week in February, it has the same day of the week in March, because February has this 28 days. So then, as you do this, then let's look at the other pieces. 31. What is 31 when I divide by 7? It's 4. No, it's 3. 31 when I divide by 7 is 3 because of 28. And here's another 3. And actually, I'll show you another trick. For 13, if I divide by 7, 13 is really close to 14. I'm going to call that -1. I can, because I'm just going to see what the remainders are when I divide by 7. How easy is it to add up 3, 0, 3, and -1? That's easy. That's 5, which is actually what we have exactly here. The -1 at the end gives you 4. So these are 2 ways to see how to calculate this out. The last thing I promised you is a little bit about the history of leap years. Over here, we had said leap years are multiple of 4 except multiples of 100 except multiples of 400. Why is that true? Actually, the reason that's true is because you may think that Earth has 365 days to go around the sun. But if you think about physics and nature, there's no reason why the number of rotations the Earth makes around its own axis should be related to the amount of time it takes to go all the way around the sun with an integer with a whole number division. It's actually quite a coincidence. It's a really nice coincidence that this is somewhat close to an integer. When I say somewhat close to an integer, I mean somewhat close to a quarter of an integer. You see, the actual number of days in a year is 365.24219. Okay, so this is not 365. But the really nice thing about this number is it's very close to 365.25. That's why we can have leap years. Because with leap years, we can add on about a quarter of a day, because basically every 4 years, you get 1 day. Just imagine, if this number hadn't been 0.24, but some other horrible number like 0.23, the leap year rules would have been even more complicated, because we wouldn't be so close to a nice fraction at the end. Let's look a little bit at the details of the leap year rules also. The leap year rules say that every 4 years, you get 1 day. So actually that gives you plus 1/4 day. Okay? But if you just did that, then every year would have 365.25 days, which is too much. So the correction that people made is they took minus 1/100, which says that every 100 years, that's not a leap year. If you put these two together, what this is easy because this is 0.25 minus 0.01. This is 0.24. If you only had those rules and stopped there, then you would actually have that the number of days in a year was 365.24, which is still too short. So that's actually the reason why people made a rule saying actually you should also add plus 1/400. What is 1/400? an easy way to see this is 1 over 400 is 1/100th of 1/4. 1/4 is 0.25. What happens when I divide this by 100? I move the decimal 2 spots. So this becomes plus 0.0025. So when you put all of this together, then with the rules that we have, the number of days in the year, all together with these two corrections that we make, becomes 365.2425, which is extremely close to what we have in the actual number of days in the year. So I wanted to use this question, which is honestly a pretty basic question. I wanted to use this question to talk about why leap years are the way they are. Look, this is nice. If this wasn't so nice, we'd have crazy rules to remember. But also I wanted to share these ideas about when you're doing calendar problems, to look maybe at gaps. That's the easiest way not to make a mistake. And the second piece is that if you're going to divide by 7 anyway, sometimes making the numbers small before you add is a good way of double checking your answer. It's often the faster way, but it's always safe to have these many ways of attacking same question in the end.